It's 10 past, so we'll get started here. My name is David Kirkwood. I am a technical CETA at DARPA, and this is Michael Anderson, who is a government employee at NIWC Pacific. And today we're here to talk to you about a couple of the DARPA programs that are focused around 5G. We're calling this DARPA 5G portfolio. It does not quite comprehensively cover everything that DARPA is doing, but it's a good reference example for DARPA's focus here and points to larger interest in the DoD towards 5G and open source software solutions. So DoD and 5G. DoD is interested in having access to open, secure, and trusted 5G solutions. This graphic here we've been presenting for quite a while, and it's very cartoony, but it gives a good understanding of the motivation behind why DoD is looking at 5G open source solutions. And really, if you see on the bottom left there are uncontested environments in which commercial technology is openly available and works quite well. And then there are very sophisticated, very expensive DoD components that are purchased in order to provide those same types of capabilities to the warfighter. And ultimately, what we're trying to get towards is the point where the DoD has access to equipment that provides the same level of functionality that is available with commercial software, but provides it in a manner that gives the warfighter a secure access to communications is done so on a trusted ecosystem. So, like I said, we're not going to cover everything, and even these three programs here aren't fully encompassing of what DARPA is focused on. But mainly today we're going to talk to you about two programs, the Open Programmable Accelerated 5G program and the Open Programmable Secure 5G program. All three of these were started under the same vision at DARPA and really meant to develop technologies to provide an end-to-end open source software solution for the DoD to develop networking capabilities on. So that's really the crux of this chart here. We have on all of these programs a core group of performers that are doing a lot of the technology development, and then a core group of government entities that are involved with doing integration, testing, red teaming, and capability development on these software solutions. And so that's it. I'm going to hand it over to Mike at this point to talk about the OPS, and come back later.
Sure. So thanks everybody for the opportunity to present. So just some background. I previous military, I went back into private sector and I worked in the commercial wireless industry in San Diego, kind of during the heyday. So on CDMA handsets, 802.11 chipsets, and I circled back and working with the government again. And so it's a really kind of an exciting time to be involved with this whole open source community, and now the government is trying to figure out how we can take advantage of the advancements in the commercial sector, right? Which is kind of a paradigm shift from the way the government used to work. The government used to develop technology and push it to the private sector, but 5G is, I think, one of the first efforts where the government is really looking to the private sector community to lead us into this new world of how can the government utilize 5G. And as David alluded to, there are some key components for the government to be able to leverage this open source community, right? Well, the first, of course, is the openness of the software. So we'll talk about why the openness is so important, but I think everybody here is familiar with that. The second thing that is, maybe not any more important to the DoD, but maybe we have some specific goals, is the secure portion of what we're talking about. And that's really when, these two programs, OPS and OPA, which deal with the core and the RAN, start to focus on how can we secure these open solutions to the point that they're ready to be deployed for a private network within the DoD. Right? And one of the goals is to understand, as the government, how can we take open source code, provide some enhancements through funding research efforts, and feed those enhancements back into the open source community. So that's really the goal. So this first effort on ops focuses on the core network, The second topic we're going to discuss focuses on the RAN solution, really. So we've got, we still have quite a bit of time. So if you have questions during this talk, I'd encourage you to speak up, please. So don't feel like you need to wait until the end of the talk. We're like I said, we're here to leverage, this technology from the open source community. So we'd like to hear your ideas too. So if you have a comment or a question during the talk, please just raise your hand or speak out. So Ops 5G, as I mentioned, so that deals with the core network, and so really, I think what we're talking about here is the the difference between a proprietary solution and an open source solution. So obviously, the open source solution, some might say it's less secure, or is the proprietary solution less secure because it's a black box. But what it really comes down to from a government perspective is the government is not interested in black box solutions. Something we don't know what the code, we don't know what the code is, we don't know what the hardware is. And in this case of the ops, right, we were talking about a hardware abstraction layer between the software and the hardware. And really the question is how can we fund research to help improve that abstraction layer? So I'm just going to talk about 3 efforts. There are multiple things going on with ops. I think these are the 3 most relevant. The first one, where standards meets software. I'm just going to briefly talk about this because I think it's a really interesting academic research topic. And what this is dealing with is taking the standards documents. Everybody's familiar, I think, with 3GPP standards documents, and trying to understand how to do natural language processing in order to actually develop code based off of those standards documents. So there was an effort to develop some code based off standards, and they did make some progress on that. I don't have a demonstration of that, but I did want to just briefly mention that because I feel it's a really interesting research area. The 2 areas funded by ops that I do want to talk about have to do with network slices as well as defenses. So for your reference, there is a talk later today at 5 o'clock from USC to discuss the network slicing portion, and that's from Dr. Klein in the Willow Hall at 5 o'clock. So the two topics I do want to discuss specifically have to deal, as I said, with topics 2 and 3. So moving on to this first topic, right, which is related to secure slices through an effort that was funded at USC-ISI. And that's the effort that I talked about is going to be revisited today at 5 o'clock tonight. So that's a project called SABRE, if anybody's familiar with that. Is Michael Klein here, Dr. Klein here, by chance? Yeah, I'm here. Oh, you are? Okay. So if you have any questions, that's your guy back there, right? So please correct me if I'm wrong on this, okay? Because our representative for ops could not make it here, so I'm standing in for him. So in general, the idea between the general idea of SABRE is you have a series of inputs, right? You've got constraints and you've got resources, and what SABRE does is manages a configuration based off of your constraints, your goals, and your resources. So there's an orchestration algorithm as well as a verification environment that will verify the slice configuration, if I'm correct, Dr. Klein. So the reason we wanted to mention this is because this is an ops-funded research effort that is contributing back into the Linux Foundation. You can learn more about that at 5 o'clock tonight. The second effort that we would like to discuss has to deal with some defense. And this demonstration is specific to a VoIP denial of service attack. This effort funded Peraton Labs to develop a response to denial of service attack specific to VoIP. And I think this will best demonstrate the success.
Reading from an article. Here we go. Emily Nunn would drive
So here's the attack. I think that was a denial of service attack on my talk.
Did you mean to turn that down?
No?
Yeah, was that supposed to?
Emily wouldn't drive on the freeway here, so it can take 45 minutes to get from her apartment to Kevin's indoor your farmer's market, whose inexpensive and thoughtful produce selection she prefers.
I think we might have even missed it there. It happens very, very quickly, but you hear, oh, there it
There's,
is.
so there you go. So the call quickly returned to baseline.
It's because I have so much fun. I don't care anymore. The word everybody is hyperbole, of course.
Okay, so there you go. So that was a second example of how the government is trying to fund efforts that will feed back into the open source community. So as I mentioned, so we've got two efforts going on. We've got one for the core, which is called Ops, and we also have an effort that's undertaking for the RAN, which is a effort that I've been involved with. Specifically focuses on the RAN and the UE. So there are multiple challenges with the RAN in addition to the core. So one of the challenges with the RAN has to do with the standards. So as you know, the bulk of the conformance testing that goes on today for a RAN has to do with testing UEs, because that's the most challenging part for a vendor, is to ensure that UEs can connect to their network successfully and there's no challenges. So one of the difficulties with this is that not all vendors test conformance the same. So for example, Verizon will have a UE go through standard conformance testing in addition to a series of tests in order to get it on a Verizon network. So the government's trying to figure out, in terms of utilizing open source solutions, how do we come up with some level of conformance that will ensure some interoperability between solutions? And this is a big challenge that we found from open source communities in general, because conformance testing isn't highest on the priority list for a number of reasons. And one of the first reasons is just the cost of conformance testing equipment. So a small open source community does not have access to the very expensive Rhodian Shorts equipment that's required to ensure that my design meets all the conformance tests. So I'll discuss a little bit later some of the efforts we have going on in order to provide this type of conformance testing for open source solutions. The second has to do with networking configuration of the RAN and the UE. So there are of course the three key performance parameters, right? We've got the EMBB, the URLLC, and the massive machine type communication. So one of the challenges for the DoD is we may not want to limit ourselves to what the commercial industry is interested in right now, which is specifically broadband. So commercial industry is really concerned about broadband. They're not as concerned about, let's say, V2X or the URLLC, which are of interest to the DoD. So that's another challenge the DoD has, is how do we embrace the technology as it comes along versus trying to stimulate areas that we're particularly interested in. The third area has to do with implementation. This one's a little bit trickier because it's an area that we're still trying to develop, which is how do we work with organizations like the Linux Foundation? How do we feed our investments back into the open source community? And it's really one of the reasons that we're here today. Right, so this is a whole new area for the DoD. One of the reasons we're here presenting to you is to let you know what we're doing and to try to get your feedback on how we can better work with the open source community. We have some ideas, and we'll be interested to hear your feedback. But in general, the idea for the DoD is focusing on this open source stack that comes from the private sector community, is enhanced by DoD, in which will feed some enhancements back to your community. So specifically for the RAN, how are we contributing back to the open source community? one of the, I think, I mentioned conformance testing as one of the areas we're trying to support the open source community. Another area that we're trying to do some research into is red teaming and understanding the vulnerabilities of these open source solutions. So this is the area, going back to my previous statement, which we're not sure how we're going to get this back to the community. As we identify these threats, do we fix them ourselves? Do we publish them to the open source community? So this is an open question that we're trying to understand how to work with you guys. So there are other efforts that we're undertaking, such as being able to port open source waveforms to multiple platforms. So I think everybody's familiar with the EDIS radios. There are opportunities to port to x86 radios as well as just FPGA stacks. Diagnostics tools and test beds. One of the big pushes we have within DoD is to ensure that we're capturing all the work that's going on within the open source community, as well as the investments we're making into trying to enhance the security. So I've got a little graphic here this is our initial push for how we're hoping to work with your community. So if you look at number one, we're in this interesting environment where we're not only the customer, but we're potentially the solution provider, right? So our customers are military installations or government organizations. So if you look at this loop, right, the operational requirements are something that we can control ourselves, right? We can decide what's important based off of what's going on within our operational need statement. So there are a number of different use cases for open source 5G within the government. We could enhance base operations. We could establish private networks and environments that currently don't have communications. It could be used strictly for training environments. So there's a long list of operational use cases for us. And we have to prioritize those, and those prioritized lists actually come from our own programs of record, which means how are we able to fund these efforts? So OUSD, with Dr. Rondeau leading that, has a talk tomorrow that I encourage everybody to attend. DARPA, of course, is focused on the research side of things. But then we also have, a whole other community of interest, which are the forces, right? So, how can we use 5G to enhance base operations? We've got a lot of military installations that, aren't necessarily the best place for commercial installations of 5G. So are those good opportunities for a private 5G network, which in theory could be deployed as an open source solution, which is really our goal. So outside of those operational requirements and the organizations that are willing to pay for the research into those, we do have to identify these research opportunities, which we talked about two of them today with ops in the core and OPA for the RAN. So both of those intend to contribute back to the open source community. So that fourth bullet, number 4, shows what we're trying to do, what we're hoping to do, is establish, if you see the DODIR, that stands for the Department of Defense Information Repository. I've got a slide on that I can provide a little more detail. So it's really, I think, if you were to think about it in terms of open source community, it's kind of a government GitHub where we're able to capture not only the open source waveform that the government has embraced, but the enhancements that have gone on through government research. So the question is, we have to decide what portions of those enhancements we feed back to the community, right? And which parts of those research we're required to hold on to for funding reasons. So the other effort we're setting up is a reference lab, and the reference lab is really the place where we'll end up doing the bulk of the regression testing on whatever enhancements are made in industry. But anyway, so the key takeaway of this is the government's investing a lot of time and a lot of money in order to ensure that we're able to collaborate with you, not only industry, but with academia. And that's because we recognize that is where the leadership and the vision is coming from for open source 5G. So this is just a little blurb for anybody that's not familiar with with the information repository. So the government already does this for waveforms. There's a number of different waveforms that are utilized by the government, and they're all managed in a common information repository. So the information repository is a place where the waveform is checked in, it's checked out, it's enhanced, and it gets checked back in. Reference implementation lab, I'm sure everybody's familiar with regression testing. It's just a kind of an industry standard environment. So government is investing in both of these capabilities, and I think our hope is to understand from today, and if through your feedback, how we can best collaborate, and where is the interest from the open source community in terms of developing these waveforms for secure enhancements, and how can we improve collaboration with communities such as yourself. So I think that's kind of the end of those slides. I'm going to hand it back to David to close real quick, and then we've got 10 minutes for questions.
So Mike hit on a couple points there that I meant to foot stomp at the very beginning here, but I'll just reinforce them here because that's really what this slide speaks to. So what this slide has on it is a number of pulled quotes from a host of memos that have come out from DoD leadership, CIO leadership, and even from releases from the White House in terms of focus areas that the military should be looking at. And if you can see, a common theme through all of these is open source solutions, something that's called MOSA, which is Modular Open Systems Architecture, and all emphasizing the push from leadership to have all of the folks that are working within the DoD on developing capabilities to be doing that development on open source solutions. And so DARPA is a research-focused agency. The efforts here that we presented on today that are funded by DARPA are looking to do research with this open source software stack that's been developed for the end-to-end network. But that pathway that Mike laid out for engaging with entities like the Linux Foundation and folks that are here is really something that at large the U.S. government is interested in pushing and understanding the best pathway forwards to do that. So yeah, I'll again foot stomp the fact that Dr. Rondeau is going to be talking tomorrow and giving a little bit more on the vision for that there coming out of OUSD R&E. But with that, well, thank you for coming, and we'll open the floor to questions. If there are any.
So I think I'd like to ask questions of the community.
Yeah, let me start. I'm Sar from Dell Technologies. Just want to understand, like, what will be the output of this effort? Will you, let's say, are targeting whatever work, because you mentioned ORAN and CORE, and obviously we have something like ORAN Alliance and ONAP.
Yep.
Will you push this to those communities? Are you redefining, like, what will be the output we expect from?
Yeah, no, definitely not redefining, but pushing everything that's developed here to those communities. So all of the output coming out of the OPA and the OPS program are going to be openly published. And then from that point forward, trying to identify what the best solutions are. So obviously there's a bunch of other work going on that's being presented over the course of these couple days here on other solutions that match and align well with what these two efforts are trying to do. So I think at that point it would be an open discussion then on now that we have started to do some development on these open source systems, how do we determine what the solutions are that everyone wants to move forward with together, so that there can be a common technology foundation that the whole community, along with the DoD, is developing on, and they can then pull as necessary or as desired the solutions from that repository, and if they want, behind their own curtain, do their own specific sauce to make it applicable to the application they're developing for, but it's all done on a common foundational technology base.
But so the end goal is to have a functioning network.
Oh yeah, well,
based on
definitely.
That's the goal. Something that we can deploy, either, as I mentioned, base operations or private networks that we're actually utilizing. So our goal doesn't. The effort doesn't end at research, I guess, is the point I'm trying to do.
Yeah.
I'm speaking, I come from the
Yeah.
And then take advantage of some of the other projects, you know, to move everything forward. So I think, again, it's a give and take.
No, absolutely. I think that kind of speaks to something Mike and I were talking about earlier in terms of, you know, obviously when you get into talking about security issues, people within the DoD get really tense and want to make everything sensitive. So, you know, what are the ways in which those things can be identified on an open source platform that is not in any way, you know, compromising a capability?
That applies to governments too.
Yeah, absolutely.
We're very obviously security sensitive.
Yeah.
And my company sells a lot of stuff to the federal government, so
Mm-hmm.
obviously we have to meet all the requirements too.
That sounds like a good point of discussion.
So one of the big 4G and 5G core projects in the open source world is Magma. So I was curious if you were involved in this project at all.
So initially, we were trying to leverage Magma, and I don't want to, is anybody here from Magma? So I think one of the challenges that we've had has had to do with and just, I'm not trying to disparage Magma or promote it or anything.
We are just at the heart of Magma. I represent Open Air Interface.
Okay,
Yeah.
So yes.
Magma is just that we have been working with Magma.
Yeah, so the original intent was to follow the blueprint, and this is one of the challenges we have, right? Since the government isn't driving industry, so some efforts have progressed faster than others, and because of that, it becomes challenging because then you're forced to kind of refocus and adopt portions of an open source solution, and you can't adopt other parts of another open source solution. So we really have to, this is one of the biggest challenges. We're at the whim of the private sector. Right? So we can't fund the entire private sector to do this, obviously, as the government. And the goal isn't to do that. The goal is to enhance what the private sector has done. So when some efforts stall, we're forced to wait. But so that's our plan, was to embrace Magma as the core for the ops solution. So we were following the Linux Foundation blueprint.
I think as that plan changes, as another core is selected by the blueprint, that's hopefully what we'll shift to. Yeah, so Tom's just saying, if you can talk to Mike Worcester. Oh, we have.
Yeah.
Got it.
Yeah, but I think that kind of highlighted one of the challenges the government has with, you know, being a user of technology rather than driving the technology. So.
And are there some timelines when we expect this, like we will share something, some output is coming?
So, well, I mean, there was output, right? So you can go listen to Dr. Klein's talk today, right? So that's an output from government investment in 5G with secure network slicing. And we also mentioned, of course, the Peraton Lab results, and there are a lot of other research efforts that are going on as well. So I think it's an ongoing effort, and we're going to incrementally be pushing things back to the community. But this is one of the challenges: is, you know, sometimes the government has to figure out what to release and what to hold on to, and that's one of the new areas for collaboration we're trying to understand.
So both of those programs are in, you know, we phase our programs and they're in phase 2, so they're kind of in the middle of their efforts. That Pronto effort that we didn't talk about today has had a number of other outputs as well. I'm totally blanking. Sorry? Yeah, thank you. That with ONF. So all of that is openly available.
Well, I think that's the time, and if you have any questions, feel free to stay late and talk to us, but appreciate the opportunity we had to come talk to you and hopefully learn some lessons here today. Thanks.
Thank you.